There is a lot of momentum within the industry for higher and higher resolution, and the need to create stunning images using high dynamic range and wide color gamut. Telestream has introduced a range of tools to simplify monitoring of HDR within PRISM, the latest generation of waveform monitor for hybrid media applications for SDI and IP monitoring of video and audio signals. There are several challenges in monitoring HDR, from ensuring the correct white, gray, and black levels are set correctly. Traditionally, in standard dynamic range, 90% reflectance white is at 100%, and 18% gray is at 43%. Now all that changes in HDR depending on whether you're using HLG or PQ. Each has its own gamma curve which changes the video levels, and means that 90% reflectance white and 18% gray are now at 58% and 38% in PQ. Then added to that the acquisition of content from a variety of different camera manufacturers, each optimizing their gamma curve for their specific brand of camera, and it can become very confusing on where the white and gray points are within the image. To demonstrate this, let's use the Datacolor Spider Cube that has reference levels for super black, reflective black, 18% gray, 90% reflectance white, and the shiny ball bearing on the top of the cube produces those specular highlights. The image on the picture display of PRISM looks low contrast, and this is because it was captured from a camera in S-Log2. That means that 90% reflectance white is at 59%, and 18% gray is at 32%. Let us take a look at this on the waveform on the display of PRISM. The standard percentage graticule shows the white level at around 60%, but I can change the graticule to look at the waveform tracing stops, where 18% gray is at 0 stop reference and white is at 2.3 stops. However, the levels in this graticule are still based on standard dynamic range, and we need to change the input gamma curve, in this case to S-Log2. We can do this in the Settings menu for one of the 6 virtual inputs, and by changing the gamma curve to S-Log2, automatically the waveform graticule changes to the appropriate levels for this input gamma. Now I can see that 90% reflectance white is at 2.3 stops, and the 18% gray is at 0 stops. So I can make sure the levels are set correctly for the acquisition of this material from the camera. To assist the user in checking the look of the image, the user can simply apply an internal lookup table in PRISM to make the conversion to standard dynamic range 709, so that they can visually check within the picture display or within the waveform display what the image would look like in a traditional SDR 709 gamma. The user can configure multiple virtual inputs within PRISM to use a variety of gamma functions available from camera log, such as S-Log2 or Log-C, to high dynamic range gamma functions of HLG and PQ. We can then save these various configurations as presets for easy recall later. Now we want to convert this camera log footage to HDR by either using the color correction controls of lift, gamma, and gain, or by applying a lookup table within our color correction application. And now I want to change the scale to be in nits. So I'll make that change within the waveform display. For HLG 1000, I would want the 90% reflectance white to be at 73%, and the 18% gray to be at 38%, based on the ITU 2100 standard. So let's make those adjustments to our camera raw footage, and make sure that the specular highlights are limited to 1000 nits at 100%. Again, we can change the picture display of this HDL input gamma to SDR 709 to provide a representation of the image within the SDR display of PRISM. Similarly, if we wanted to produce this content in PQ, then we would change the input gamma appropriately and make similar adjustments to get the white at 58% and the 18% grey is coincidentally at 38%. We would also make adjustments of the specular highlights to keep them within a specified range, such as 1000 nits for the delivery of content. You can see there are a variety of different white points to keep track of between all of these camera log formats and between the two main HDR formats of HLG and PQ. And it is challenging to make sure you have the correct levels adjusted. So Telestream developed a new stop display to simplify the process in this new workflow of HDR for PRISM. A traditional waveform display is a linear representation of the light level, including the 709 gamma for the signal from black to white. The stop display provides a linear power log representation of the trace, based on the light level. Now a user can adjust the video signal to the reference points of 90% reflectance white at 2.3 stops and 18% grey at 0 stops. So when producing a live event, for instance, you can use the white lines of the pitch for the reference white point and the green grass at the 18% grey point to make adjustments of each camera, whether you're requiring the footage in a camera log such as S-Log3 and then monitoring the output of the program in HDR hybrid log gamma. The user simply selects the appropriate gamma functions in PRISM to monitor the signal. With the stop display being based on the log function of the gamma curve, it's easy to gauge the dynamic range provided by each camera and make adjustments to maximize the performance of the camera's output, to use the full dynamic range as the operator makes adjustments of the levels of the camera. This can avoid costly retakes due to the original footage being incorrectly exposed. The Telestream PRISM provides a useful toolset for monitoring your HDR content, from HDR gradicules to the log scale of the Telestream stop display, or the variety of false color tools that can be overlaid in the picture display to help you visualize the HDR content. For more information or to arrange a demonstration, please contact your local Telestream sales representative.